Hi everyone, today's sync meet, we're going to be doing some practice. So you need to grab your notebook and we're going to be writing down some examples of some chemical reactions and how to identify which type of chemical reaction is occurring by creating an ABC model of each reaction. All right, so grab your notebook and we're going to set it up. Do example A, example B, and example C together today. All right, so let us know in the chat once you've got your notebook set up. I'm ready to go, ready to do these examples. Thanks, Dakota. Giselle's done. All right, good work. Don't forget that, whenever we have our sync meets, it's a good idea to have your notebook not too far from you and something to write with because, we do use our notebook a lot during our sync meets. Thanks, Brianna and Michelle. Only 4 of us so far, huh? Everybody else looking for their notebook or what's going on? Anna's got it.
Wow.
Awesome.
Okay, 5 out of 15.
We're getting there.
Yeah. Ciao, Linda. Morgan's ready. Hamza's
All right,
ready.
Hamza's got it too. Good work. You know what I'm seeing here? I'm seeing that the girls are really fast.
Isn't that always?
Yeah.
No,
Morgan, good job being the first guy ready. Okay, how about you, Jared? May? Naima's done. Thank you. Yell, you ready?
Alejandro.
Alejandro's ready. All right. And Camila. So I'll let you guys go back to our document here. And I wonder if I can make this bigger. I can't do presentation mode because then I can't move things around. No, it didn't help at all. All right. So the first example we're going to do, example A, is this reaction down here. Okay, so we're going to write down this reaction in our notebook. Okay, so this is what you're writing in your notebook. Galenium with a subscript of 2, oxygen with a subscript of 3. This is galenium oxide. And then over here, so this is one thing. This is a compound, right? It's actually an ionic compound because we have a metal and a nonmetal. And then over here we have the metal all by itself, galenium, and then the oxygen all by itself. All right, and then I'm going to show you what we're going to do with this on the PowerPoint to identify it and to make our ABC model. Okay, so up here, we're going to label the name of this type of reaction, and below it, we're going to create an ABC model. And if you've already done your notes, you have examples of those ABC models for the different types already. All right, so let's do the first one. I see a lot of you guys have not said that you're ready in the chat, but I hope that you're just being untalkative. All right, I hope that you actually have your notebook and are going to do this work with us. All right, so this type of reaction, let's take a look at the ABC model to make it obvious. All right, when we do an ABC model, we want to use letters to represent the different elements. Okay, so I'm just going to start with A and work my way over. So I'm going to use the letter A to represent galenium. I'm going to drag over, and when you grab these to drag them, you have to have that little cursor thing to move it, right? So hold it like on the edge and then drag it over. Since this is a compound, I'm going to make them touch. I'm going to make them overlap to show that they're bonded together to form a compound. All right, and then I'm going to grab a yield arrow because the yield arrow means a chemical reaction is taking place. All right, now I've already chosen A and B to represent my elements. So I have to use A and B on this side. Both sides of the chemical equation have to have the same letters. You can't have, for example, I can't go grab a letter C now because there is no letter C on this side. Okay, so both sides of the arrow have to have the same letters. So I already chose A for galenium here, so I'm going to use my A for galenium on this side. I'm going to grab a plus sign to show that now these two things are separate on the product side. Then I'm going to grab my B for my oxygen, okay? So based on the video and the sync meet that we did this kind of stuff together last week, does anybody remember what it's called? What kind of reaction we have when we start with a single substance that breaks apart into two or more pieces? Does anybody remember which of these is called?
Dakota got it. You
Yeah,
said the girls
Dakota's
are
got
faster
it.
than the boys. Yeah.
Yeah, the girls are super quick in this class. All right, so decomposition. So we grab the kind, we bring it over here and put that label there. All right, so this is a decomposition reaction. Decomposition means to come apart. When something, if you compose something, you're putting it together, and the prefix D means to undo. Okay, so let's go back to the notebook, and we're going to write in decomposition. And for the ABC model, I'm just going to do this. This is my compound AB, and it turns into A plus B. Now you have the ABC model for a decomposition reaction. Okay, so the ABC model is a very generic version that represents this specific chemical equation. Okay, so there's our first one. Now let's take a look at the second one, unless anybody needs me to wait. If I start going too fast and you need me to wait, just throw a W or wait into the chat, okay?
1 second.
And we will have some of this, those ones that you're doing in your own or in groups. And so just if you pay attention now, you'll be able to do it the next one.
Definitely.
Yeah, so we start with a group and we broke them apart.
Okay, so here's the next one. So write this chemical equation in your notebook, for example 2. Okay, well, like we did last time, we'll also label the type of reaction and make an ABC model for it. Here we have the element nickel, Ni. It's going to be added to the compound HCl, which is an acid. HCl is hydrochloric acid. And then they are going to chemically react, that's what the arrow tells me, to form these new substances. The compound nickel chloride, NiCl2, and elemental hydrogen. Okay, so you should have that in your notebook. Okay, one of the things you want to notice here is that this reaction has a element and a compound on this side, and it also has an element and a compound on this side. Okay, that's going to be important in identifying this type of chemical reaction. All right, let's make a ABC model. So I'm going to grab the letter A, and that's going to represent my nickel. So remember, it's also going to have to represent nickel on this side as well. Okay, I'm going to grab the letter B to represent hydrogen. And I'm going to grab the letter C to represent chlorine. I have to attach the chlorine to the hydrogen because they're chemically bonded right now. They have an ionic bond. All right, and I'm going to put a plus sign between those two. Yield arrow to show a chemical reaction is happening. And now I'm going to show how these recombine to form new substances. Okay, so I've got my A for nickel. Remember, I used C for chlorine on this side. So I'm still going to use C over here, but I'm going to bond it to the nickel this time. And then I'm going to use my B for hydrogen. Okay, so what really happened here, the only thing that happened here is that A and B swap places. A and B switch places. Okay? So does anybody know what type of reaction this is? Where we have a single element with a compound, and that element changes places with one other element in the compound? Ah, Michelle, good work.
Michelle got it.
Okay, so Michelle said single replacement, and that is correct, right? So there's a couple ways you can remember that this type of reaction is single replacement. Okay, the way I like to remember it is it's the only one where you have a single element on both sides. You have a single element on both sides and a compound. Okay, so there's only one replacement that's happening. A and B are swapping. It's only one swap. All right, so back to our notebook. The ABC model for a single replacement reaction is going to be A plus BC, and then the A and the B are going to swap places. So it gives you AC plus B. All right, we have one more example to do, and then you guys in small groups are going to do some of these on your own. I'm going to give you a copy of these slides. All right, last one we're going to do together, and now you're going to see something new, okay? So go ahead and write down this chemical equation. And one of the things I want to point out to you are you're going to see some elements that are inside parentheses. Okay, and we treat those a special way, and I'm going to show you how after you write this down in your notebook. Sorry, forgot to unmute myself. Okay, so during a chemical reaction, everything inside the parentheses is going to be treated as if it were an element. It's a group of atoms that will not come apart during the chemical reaction. Okay, so during the chemical reaction, the magnesium will separate from everything inside the parentheses. This stuff will stay together. Okay, so we'll have this OH.
So that will be represented one letter in the
Yes.
ABC model? Okay.
Yeah, so we'll represent the things inside parentheses whenever you see parentheses with a letter, with a single letter. All right. So let's, and actually I could continue now that I've got my highlighters out. One way that you can take a look at these is to show with colors kind of how they rearrange spaces, right? And so this is what's going to happen with this equation, right? So that each color is going to be a letter. All right, so let me go back here. All right, so I'm going to grab the letter A for my magnesium. I'm going to grab the letter B for all the stuff in the parentheses. This actually, if something is in a parenthesis, they actually have names because these groups of atoms are really common. And so whenever you see a group of atoms with the OH, that's called a hydroxide. I'm just giving you a preview of stuff you're going to learn in chemistry. You're going to learn all about these little, we call these polyatomic ion groups. All right, and then I have a hydrogen over here. So I'm going to grab a C for that. And here's another group. This group has a name. It's called a nitrate. And so I'm going to grab a letter D for that. And then I'm going to show a chemical reaction is going to occur. And I'm going to swap these around. Okay, now instead of having a single exchange, this time we're going to have basically two exchanges because we're going to form two new compounds, right? Last time we formed a new compound and got a single element. This time we're going to have two new compounds. Okay, no single elements here. So even though I say two exchanges, it's kind of splitting hairs. All right, so I'm still going to leave the magnesium with the letter A, but now the magnesium has swapped to combine with the nitrate. So let's grab the letter D. And then here's my hydrogen, which I chose the letter C for over on this side. So I'm going to use it on this hydrogen as well. And then I chose the letter B for the hydroxide group. So I'm going to keep the letter B for the hydroxide group over here. All right, so here's my ABC model. Anybody want to take a guess? Somebody who hasn't guessed yet? What do you think we call this type of reaction where we have two compounds on both sides? Somebody make an educated guess, or maybe you already know because you remember from last week. Isabella said combustion, and that is a good educated guess because combustion looks similar to this, except for combustion does have a single element on this side. Okay, so there's only one where we have two compounds and then gives you two compounds. Which of these names basically has the word two in it?
Ms. Gillison, Donna get it already.
Okay, good. Double replacement. The word double means two, right? So we have double compounds on this side and double compounds on this side. All right. Okay, I also want to show you something interesting after we do this. ABC model. So here we have A and B, C and D. And really we just had a swapping, right? So they switch partners. Okay. This one right here, HOH. You guys are very familiar with this compound. This is a new way that you can write H2O, right? So this is actually, um, this right here is the reason that water can dissolve so much stuff. You know how we dissolve practically all of our chemicals when we make solutions? We dissolve it in water, so we can mix them together. The reason why water can dissolve things is that it exists in this form right here, even as a molecule, right? So water does the, oops, H2O thing where this is a H, this is a H, this is a O, but they can be separated. So really cool. Water is actually, it is like the most interesting molecule there is. So, okay, that's all we're gonna write in our notebook. You don't have to turn that into me, but you can use it to help you on the practice that you guys are gonna be doing in groups. All right, so once you're in your groups, you're going to then take care of these 5. You'll do these similarly to how we did examples A, B, and C. All right, you'll drag letters over to create an ABC model, and you will decide which kind of chemical reaction has occurred and drag that over here. Okay, so you have 5 of these to do, and at the end of class, I'll hop into your breakout rooms and let you know if you did them correctly or not. So pay special attention to number 3. If you didn't watch the video from last week or you missed last week's sync video and you haven't done the notes yet for this week, this is going to be a challenging one for you. All right, so if you're watching this and catching up with this because you missed the sync meet on Monday or Tuesday also, I would recommend doing your note taking for this week and then coming back and doing 1 through 5. All right, so after you've done your note taking for this week, these will be much easier to do. All right, and we're going to do a lot more of this practice when we meet. We're going to do part 2 of identifying types of chemical reactions when we meet on Thursday and Friday of this week. And that is it. All right, so part 2 is the part that we'll be turning in. So let me know if you have any questions. Remember, I have office hours every day from 1 to 2:30. You can find the link to those office hours by clicking any of our Google Meet links. All right, see you guys soon.